Introducing the group for physicists. We have Natalie, Marvin, Angeline, Micah, Ashley, Ella, Mia, Greasy, and Jeremiah to present to you the concept of atmospheric pressure.
Have you ever heard anything about the concept of atmospheric pressure before?
If not, then allow us to enlighten your minds about this concept through simple and safe demonstrations.
Let us show you the true power of atmospheric pressure.
And providing the application of this concept,
We will be able to bring life to the concept of
Atmospheric pressure.
Atmospheric pressure is also known as air pressure or barometric pressure. It is a pressure within the atmosphere of the Earth.
Did you know that in 1644, an Italian physicist and mathematician named Evangelista Torricelli discovered the concept of atmospheric pressure? Torricelli was told by Galileo that he should use mercury in his vacuum experiments. Torricelli filled a 4-foot-long glass tube with mercury and inverted the tube into a dish. Some of the mercury did not escape from the tube, and Torricelli observed the vacuum that was created.
Evangelista Torricelli became the first scientist to create a sustained vacuum and is also the first to discover the principle of a barometer.
A barometer is a device that is used to measure atmospheric pressure.
Have you ever wondered why our ears pop when we climb up on a mountain? Our ears pop in high altitudes due to the sudden change in pressure. To explain, the popping occurs when there's a difference in the pressure between the two sides of our eardrums. This pressure difference creates a feeling of fullness or clogging in the ears. The sensation of stuffiness occurs between the eardrum, which separates the outer ear from the middle ear, is either stretched or pulled due to unequal pressure on both sides. The imbalance of pressure also can impair your ability to hear well, making sounds feel muffled or distant until the pressure is balanced again.
this was made possible by atmospheric pressure.
Atmospheric pressure falls under the Pascal's principle, which states that if an external pressure is applied to one part of an enclosed incompressible fluid, the pressure on any part of the fluid increases by the same amount. This principle explains why we use syringes, air pumps, hydraulic lifts, a drinking straw, a dropper, or a rubber sucker.
Isn't it fascinating that even the simplest things has their own explanations, right? Well, speaking of simple things, have you ever watched a plane take off and wondered how that big metal object actually floats in the air? Although the science behind flight may seem complex, it boils down to the 4 fundamental forces which are lift, weight, thrust, and drag.
Lift is the upward force that is created by the movement of the air above and below the plane's wing. The air flows faster above and slower below the wing, creating pressure that keeps the plane stable and flying in the air. However, weight pulls the plane down due to gravity, but the lift stabilizes the plane. Thrust is created by the jet engine or propeller, which move the plane forward in the air, countering drag, which is the air resistance opposing the forward movement of the plane.
Both of these questions were answered by one thing, the atmospheric pressure.
To further explain the concept, we have provided 5 demonstrations that will illustrate the atmospheric pressure.
Here are the following demonstrations that we're going to execute.
First is the balloon in a bottle experiment. In order for us to accomplish this demonstration, we must do the following steps.
The first step is to prepare 2 bottles and 2 balloons.
Next is to drill a hole at the bottom of each bottle.
The third step is to place the balloon inside the bottle.
Now let's try to inflate the balloon while covering the hole.
It's not inflating. Why is that? To explain, the balloon couldn't inflate because the air inside the bottle is taking up space, and when we try to inflate the balloon, we're trying to add more air inside, which will be hard because there's air already compacted in the bottle, leaving no room for more.
Now let's try uncovering the hole.
Easy, right? It worked properly because after uncovering the hole, we let some of the air that was stuck or trapped inside, thus allowing air to go through and inflate the balloon.
But what will happen if we cover the hole again? Will it stay inflated or deflated?
Whoa! Check it out! By sealing the hole in the bottle, the pressure that was compacted inside was pushed out immediately. The phenomenon caused this balloon to deflate and the bottle to crush.
Get ready for our second demonstration, the pressure fountain experiment. Time to get creative!
Here's how we make the magic happen. Fill that bottle up with water. Let's get it nice and full.
Then, slide a straw into the hole. Now for the fun part. Blow up a balloon and place it over the bottle's opening. Get ready, because things are about to get explosive.
In this experiment, the high pressure from the balloon pushes its way into the bottle, transferring all that power and forcing the water to shoot out of the straw.
Wow! Unbelievable!
Alright, let's dive into the third demonstration. Are you ready?
I know I am. I'm sure you're all too.
Okay, let's get to it. Time for the third experiment. Ready?
Ready! This one's called the mallow experiment. Trust me, it's going to be a marshmallow magic. Time for a marshmallow mystery.
We're about to take apart this syringe and give it a fun twist.
First, we pop a little marshmallow inside, then pull back the plunger. As we do, the volume inside the syringe expands, and boom, the pressure inside drops lower than the outside air, puffing up as the air around it pushes in. Watch it expand, like it's escaping into a pressure-free zone.
And here's the twist. When we pull the plunger back in, the pressure inside the syringe goes back to normal, and whoosh! The marshmallow compresses right back to its original shape. It's like it's saying, okay, I'm back to reality!
We are now on to our fourth magic trick.
Magic trick?
Yes, you heard that right. Magic trick. Because I bet this one will blow your brains out. Are you ready?
Ready!
This trick is called Where Did the Water Go? You might be wondering why is it called like that? Well, first things first, let us first gather our materials. I have here a hose and a plastic cup filled with water. Hold this please. Thank you. I'll put this water inside the hose. Now, what do you think will happen if I tilt this hose? Water is spilled, right? Well, watch this. Hold a second. If I put this water here, and level this other end of the hose like this, and the other like this, and put my palm at this end, what do you think will happen? Let's find out.
Where did the water go?
I finally answered your question. Now, this occurring happens when the water inside did not spill because the pressure inside the hose is balanced. The water inside the hose is being held in place by the force of atmospheric pressure and the water's own weight. Once you seal the end of the hose, the water cannot escape because there's no opening for it to flow through. If I let this go, the water flows out. Isn't it incredible?
And for our next demonstration, we have the candle experiment. Atmospheric pressure is important in the candle experiment as it influences the observed phenomena. When you heat up the candle within the plate, it heats the air above it, causing it to expand and some to escape.
When the glass cup is placed over the candle, the flame consumes oxygen, cooling the air inside the cup and decreasing pressure. As the air pressure inside the cup decreases, the higher atmospheric pressure outside pulls down on the water surface, forcing it to rise inside the cup.
This procedure demonstrates how variations in temperature and pressure interact, exhibiting the fundamental principle that gases expand when heated and contract when chilled, resulting in apparent effects in liquids due to atmospheric pressure.
natin, lagyan natin sa bloopers yung bago natin.
May hole yan, guys. May hole.
As you can see, the bottle has a hole. Now we put the cap on the bottle. When you pour it down, it only drips and drops. But when you release the cap, it will start to pour out. Why? Because of atmospheric pressure.
Bleepers.
Have you ever heard anything about the concept of atmospheric pressure before?
Happy birthday! Walang cake, pero may candle. Happy birthday na tayo.
Kantahan natin sila.
Happy birthday to you! Walang cake, pero wish ka muna.
Wait! They don't know. Teka! Hindi ko makalang... Commercial. Real or fact?
Hey, yan!
Ano ba yung lako? Ano ba yung lako?